I just saved us all from Earth's deadliest animal. Not a bear, not a shark, the almighty mosquito. But if you think stopping this killer is that easy, think again. Mosquitoes are lethal because they carry viruses, the real culprits behind a deadly takeover. In over 30% of infections, these viruses take over the brain, causing fatal inflammation. The goal of my research is to stop these criminals, and the first step is finding out how they're breaking in. You see, the brain isn't just any organ, it's the crown jewel, a high-value target, rich in resources and hidden from the immune system. So, of course, it's well guarded by something called the blood-brain barrier. Think of it as a fortress made up of several locked doors, accessible only to the essentials like oxygen or sugar. This is a huge obstacle for viruses trying to access the brain, so how are they breaking in? Well, my research exploits a special twist. Not all viruses in the same family can do it. Take Zika and yellow fever, close relatives, yet Zika reaches the brain and yellow fever doesn't. That makes them the perfect case study. Like a detective, I recreate the scene of the crime in my lab by growing blood-brain barrier cells and studying their interactions with two viruses, one that can invade the brain and one that can't. This led me to my first clue. Neuroinvasive viruses like Zika infect these cells way more efficiently. But how? To find out, I repeated these infections, but tweaked the virus a little along the way. This led me to my next two clues. First, the major difference lies in the outer proteins, or the hands of the virus, which allow them to grip onto cells. And second, these hands determine how sticky a virus is. Neuroinvasive viruses have stickier hands that allow them to better attach to the barrier, and that makes all the difference. In the end, I found that neuroinvasive viruses are like master thieves. Their sticky hands help them latch onto the barrier, efficiently pick the lock, and slip through to the crown jewel. Non-neuroinvasive viruses, they just can't get a grip. But my work as a detective isn't over, because we still need to stop these criminals. We now know that neuroinvasive viruses have stickier hands, but what are they holding on to? The answer is one of the many doors of the blood-brain barrier. My most recent work identified the exact door that neuroinvasive viruses are using to break in, and I proved that blocking this door is critical to preventing barrier infection. My research lays the groundwork for new medicines that will seal these doors off for good, protecting our crown jewel and stopping the real culprit behind the almighty mosquito. Thank you.